All right, next we have the 18th hole, a bit more of a practical example. The 18th hole at a golf course has a tee at T, a hole at H, and a dog leg at D, very sharp dog leg. If TD equals 112 metres, and they've given us that, and DH equals 78 metres, and they've given us that, and HDT equals 22 degrees, which they haven't given us, but I'll write in. Find angle HTD, sorry. Angle HTD, 22, they have given us that. And angle, we need to find angle TDH, which we'll call theta. Okay, so apart from pretending like it's a real world example, it's basically the same. So having drawn the diagram, you can see it's the same work we've been doing. And one of the only differences here is that instead of having the triangle called ABC, it's called TDH. And so we know how to adapt that formula. We just write that T over sine T equals D over sine D equals H over sine H. It might be worth having a go at the flipping it. So just to demonstrate that, because it does sound like it's easier, is strangely that this, because everything's ratios and proportions in triangles, is you can actually flip that whole formula and say sine T over T equals sine D over D equals sine H over H. So we might have a go with that one and see whether it's easier for you guys. So let's work out which part of the formula we actually need. We're interested in the angle at D, so we're probably going to use that bit. We don't have a side D though, so that could be tricky. We do have an angle here at T and a side, so that's good. We're definitely going to use that because we've got both bits of it. Here at H, we have a side, but no angle. So H, we have the side H, but we don't have the angle H. So that's going to be quite tricky, I think. So we've got side, we don't have D. All right, do you know what? I think first of all, we're going to have to find that side. I think we're going to have to use the sine rule to find the side. So I'm going to go back to the first version of the formula, I think. And so we've got sine, so we're interested in this side D first of all. So sine T, we've got T. So we've definitely got that bit. We're interested, we still don't know theta, and we're interested in the side. And then if we go to H again, we've got H. Oh, I'm actually stumped by this one. Yeah, brain's not working first thing in the morning. So since D's not known, D cannot be calculated, the sine of H can be calculated. This can, however, H can be calculated. Okay, so H can be calculated, and then this could be used to find D. Right. So, exactly, right. So we can use the sine rule to find this value H. Let's call it alpha. So let's do that. So let's do our values. So we've got the value there, 78 for T over sine of T which is sine 22, equals, we're using this bit to find alpha. So h is 112 over sine alpha. Okay, we need to solve for alpha. So this is the work we actually did last week, using the sine rule to find an unknown angle, because once we know that angle, of course, we can work out that angle. So if we multiplied both sides by sine alpha, it's going to cancel on that side, and we're going to get 78 sine alpha over sine 22 equals 112. I'm going to multiply both sides by sine 122, by sine 22, sorry. It's going to cancel on that side. And I've got 78 sine alpha. And I just want sine alpha by itself. So I'm going to divide both sides by 78. So that should get me sine alpha equals 112 times sine 22 over 78. Now we should be able to get a value for that, so that's what I'm going to do next. Using the calculator that works this time. So I get 0.5378. 0.5378. So we've got sine of alpha equals 0.5378, but we actually need alpha. So we can do sine to the minus 1 of 0.5378, and that will be equal to alpha. So let's do that. So I then get that angle being equal to 32 degrees 0.54056. Then of course to find theta, we need to add all the angles together to get to 180. So if I add 22, I get 54.54. What remains to get to 180 is 125. To the nearest degree, it's 125 degrees. Okay, with that one being 33 degrees. All right, button.